Edge computing, security and privacy. I am Dr. Rajiv Mishra, Professor, Department of Computer Science and Engineering, Indian Institute of Technology, Patna. Contents: we will look into the security threats in MEC, then DDoS attacks and defense mechanisms. Then we will look into the different type of attacks in the edge computing system, such as flood based attacks, 0-day DDoS attacks, side channel attacks and defenses, data perturbation, various type of injection attacks, authentication and authorization attacks, access control and authentication protocol. So, we will confine these kind of attacks or security threats in the edge computing scenario only. So, let us see about the MEC paradigm. Here you can see that in this particular figure, that here there exists a base station, and along with the base station you will see this kind of MEC servers are there. So, you can see that the deployment. So, what is being shown over here in the conventional cloud computing. So, conventional cloud computing does not have this edge, whereas this is the edge computing. So, along with the base station you will find the edge servers. So, after the edge server you will get the cloud. So, this is the cloud, this is the edge. So, edge servers are with the base station, and here are the devices. So, the devices or the applications which are latency sensitive applications, they have to now being served near to the base station or near to the source. They are called MEC, multi access edge computing. So, as the user or the application is mobile, then it may reconnect to some other kind of MEC. And if, let us say, beyond that, if it is not a latency sensitive application, then it may offload the computation to the cloud. So, when the load comes into the system of this kind of 5G or 6G, 5G, then it has to be identified whether it is a latency sensitive application or something else. Then in that case, if it is a latency sensitive application, whether it requires multi access edge computing or a cloud computing, that has to be now decided with the due intelligence. And here this is the scenario when edge computing was not there, was only the cloud computing. So, the computation offloading or task offloading has to be done with the latency to the cloud, and these cloud data centers are located at different part of the globe. So, therefore, cloud computing are having the drawbacks such as it is having a huge amount of latency, jitter, locational unawareness, insecure data outsourcing and limited access and bottlenecks. Now, with this there introduced is MEC. So, MEC is introduced now in between the cloud and the base station, called multi access edge computing. The benefits which this particular multi access edge computing will bring into is ultra low latency. So, the latency now becomes an ultra low latency. So, most of the latency sensitive applications are now possible in this particular MEC paradigm. The second important aspect is called locational unawareness. So, this is to be changed to location awareness. Why? Because now the computing is done in that vicinity of that user. So, therefore, all the location information is being preserved. Unlike here, all the data, if it is being sent to the cloud, that means location awareness, it is a location unaware type of computational offloading is done. Now, with the MEC, this is the locational awareness. So, this is very important. So, many type of location based services are now possible in this multi access edge computing. Then next important thing is in proximity data outsourcing. So, in proximity data outsourcing gives that it removes this insecure data outsourcing with the in proximity data outsourcing. Now, it is having the improved capacity at the edge, which was not there earlier. Now, it has the higher bandwidth. Why? Because most of the computation is done very close by. So, backhaul bandwidth is already available. So, higher bandwidth is available and real time responsiveness is there. So, with this, now you know that the applications such as video streaming, AR and VR, tactile internet, MTC, M2M and V2E, there are different type of applications which are now possible in this particular edge mobile or multi-access edge computing paradigm. Now, let us see about the security threats in this particular domain, that is called edge computing. So, the edge computing is a paradigm that shifts the data processing services to the network edge. That means, where it is shifting from cloud. So, the edge architecture provides a faster processing and response among various other benefits. So, emergence of edge computing introduces more security threats, since it increases the real world attack surface from the following 4 angles. So, let us see why the security threats are more here when you talk about the edge computing. First is that weak computation power. Now, you know that compared to the cloud servers, the computation power of the edge server is relatively weaker. So, this weaker form of computing power with the edge is one of the weak computing power is attracting towards the security threats. So, the edge server is more vulnerable to the existing attacks and may no longer be effective against the cloud servers. So, cloud servers are more secure compared to the edge servers. Now, compared to the general purpose computer, edge devices have more fragile defense system, and as a consequence many attacks may have been ineffective against the desktop, can impose serious threats to the edge devices. So, second security threats in edge computing is called attack unawareness. So, unlike general purpose computers, majority IoT devices do not have the user interface, regardless of the fact that some may be having the LED screens. So, user may have the limited knowledge about running status of the device, and even if an attack is taken place in an edge device, most users may not be able to. So, therefore, attack unawareness is another issue or a security threat here in edge devices or edge computing. Now, coming third threat is called operating system and the protocol heterogeneity. Unlike general purpose computers that tend to use standardized operating systems and communication protocols, most of the edge devices have different operating systems and protocols without a standardized regulation. This is also, and this problem directly leads to the difficulties of designing a unified protective environment for the edge computing. Finally, it is a coarse grained access control system which is being implemented in edge computing. So, it is access control models are designed for general purpose computer and cloud computing, mainly consist of 4 type of permissions: no read write, read only, write only, read and write. So, such a model would never be satisfiable in a edge computing due to the more complicated systems and their enabling applications, which call for fine grained access control that should handle questions such as who can access which sensor by doing what at when and how. Unfortunately, current access control models are mostly coarse grained. So, let us go inside with this understanding the edge computing security and privacy. So, attacks targeting the edge computing infrastructure have a drastic rise in the recent years. One of the most notable attack happened in the real world is Mirai attack, which Mirai virus. It managed to compromise more than 65,000 IoT devices within first 20 hours after its release in 2016 by exploiting the device's weak authentication vulnerabilities. A few days later, these compromised devices were turned into the botnets to launch DDoS attack against the edge server, shutting down around 1,78,000 domains. Shortly after that, variations of Mirai such as IoT Reaper and Hazami were captured, and they were believed to infect more than 378 million IoT devices in 2016. Since the discovery of the first Mirai botnet in 2016, IoT botnet attack were reported to cost the damages worth 100 million US dollar by September 2018. These numbers only indicate the attacks and the asset losses that were officially identified and reported. The total amount of undirected attacks and losses should be much more higher. So, if you see the edge computing security and the privacy, that is the percentages according to the type of attacks targeting the edge computing infrastructure that has happened in the real world. So, what you will find in that the most prominent of these attacks are DDoS attacks and malware injection attacks with a 26% of its share. That is DDoS and the malware injection. Whereas side channel attack contributes to 8% of the edge computing security and privacy. Bad data induction attacks is 9%. Man in the middle is a 9%, and authentication and authorization attacks is because of 22%. So, let us see that these are the most important security attacks that we are going to see in the edge computing scenario. So, we will now summarize the major state of the art security threats and the attacks faced by the edge computing. We then explore the corresponding defense mechanisms, which are either the detection based for the purpose of recognizing the attacks, or prevention based for objective of obstructing the attacks from happening. Lastly, we outline the root causes of the attacks and discuss the practicality of launching and defending them. So, let us start with the DDoS attacks and the defense mechanisms. So, DDoS refers to the type of cyber attack in which the attackers aim to disrupt the normal services provided by one or more servers based on the distributed resources, such as the cluster of compromised edge devices, such as they are called, also known as botnets. Now, this particular attack is a powerful attack that aims to prevent the legitimate use of service. A traditional DDoS attack occurs when an attacker persistently sends a stream of packets to a victim from compromised distributed electronic device. Thus, the hardware resources of the victim are quickly exhausted for handling malicious packets and can no longer be the process any legitimate request on the time. In some other denial of service DDoS attack scenarios, an attacker persistently sends malformed packets that confuse an application or a protocol of the victim to falsely conclude that all the channels and the resources are occupied. Now, compared to the cloud servers, edge servers are more susceptible to the DDoS attack, since they are relatively computationally less powerful to maintain a strong defense system as the cloud servers can defend. Edge servers mainly provide the services to the edge devices that are well known to the error prone in the regard to the security settings due to the computation limited hardware and heterogeneous firmware. Having noticed The error-prone edge devices, attackers favor first compromising a number of edge devices, turning them into the weapon against the edge servers. So, here you can see that this attacker will take a control of these particular devices, and they are now become the rogue edge devices, and this is the typical architecture of a DDoS attack, and then use this particular devices to inject unnecessary or information into the system, thereby avoiding this particular edge server to respond with all that with legitimate kind of requests. So, flooding based attacks is quite prevalent and are a type of DDoS attacks aiming to shut down the normal service of the server based on the large amount of flooded, malformed and malicious network packets, are mainly classified into UDP flooding, ICMP flooding, sync flooding, ping of death, HTTP flooding and slow race according to the attack techniques. So, in a UDP flooding attacks, an attack continuously sends large amount of noisy UDP packet to the target servers, causing the server incapable of handling the benign UDP packets in time, thus interrupting the normal UDP services provided by the UDP, the edge servers. ICMP flooding attack, similar to that particular UDP flooding attack, the attacker exploits the ICMP protocol to craft an attack by sending large number of ICMP echo request packet to the target server as fast as possible without waiting for the response. Now, zero-day attacks is more advanced than flooding based DDoS attacks earlier, but it is more difficult to implement. The zero-day DDoS attack, and here an attacker finds an unknown vulnerability, that is zero-day vulnerability is a piece of the code running on the target edge server or a device which can cause the memory corruption and finally result into the service shutdown. Now, current defense solution, the root cause of flooding based attacks is the protocol level design flaws and vulnerabilities within the network communication protocol, while the root cause of zero-day attack lies in the code level vulnerability that can trigger the memory failures and the corruptions. So, the current defense solution against the flooding based attack mainly adopt to detect the filter philosophy, while those against the zero-day attacks mainly focus on the code level vulnerability identifications. Now, detection of the flood based DDoS attack can mainly be classified into two categories: per packet detection. The other is statistics based detection. Per packet detections aim to detect the flooding based attacks at the packet level. Since the flooding based attack is launched mainly by sending enormous amount of malicious or malformed network packet, detecting and filtering those packets can have an effective defense. When a suspicious packet is identified, the network can simply drop the packet before it arrives at the destination edge servers. Although this may sound trivial, detecting whether the packet is a DDoS or a oriented malicious, one is never safe. Now, to defend against zero-day attack, the researchers have developed the mechanisms such as pointer taintedness detection and ECC memory to spot possible memory leaks in a program. Such methods require presence of the original source codes, which are usually unavailable for the edge devices. So, there are several researchers propose the approach to perform the memory analysis based solely on the firmware. So, there are various deep learning models also, recurrent neural networks, graph neural networks and deep natural language processing can identify these vulnerabilities in the firmware with higher accuracy rates. Now, coming to next type of attack, which is called side channel attack, and let us see its defenses. So, side channel attack refer to those that compromise the user security and privacy using any publicly accessible information that is not privacy sensitive in the nature, namely the side channel information. Such public information is typically correlated secretly with certain privacy sensitive data that should be protected. Attackers then explore the hidden correlations to finally infer the protected data from the side channels. Since any public information can have the potential to link some of the sensitive data, side channel attack can happen anywhere in the edge computing architecture. An attacker constantly obtains the side channel information from the target edge computing infrastructure, then feeds it into the specific algorithms machine learning model that output the desired sensitive information. The most popular side channels in the edge computing include communication signals, electric power consumption, smartphone or embedded sensors. The attacks exploiting the communication channel happens when the attacker continuously monitors the transmission between two edge nodes. Those exploiting the power consumption often occur after the attacker steals the power consumption data of the edge devices, and those exploiting smartphone based channels happens when the attacker secretly accesses the smartphone and steals the information stored in publicly available procedure files or generated by the embedded sensors. So, here you can understand this particular attacker. So, it can obtain using the available information, that is traffic streams, power consumption, timing, etc. Then it will use this information to infer the private information, location, password, activities and so on, that will infer, and then it will target the edge computing system, and this is the typical architecture of a side channel attack. So, attacks which are exploiting the communication channels in the edge computing, exploiting the communication signals has a high potential to reveal the sensitive information of a victim due to the rich channel information. So, attacker can be any curious malicious node which does not have an edge device or an edge server who continuously sniffs the network traces and wishes to extract the sensitive information out of that. This type of attack can further be taxonomized into two subclasses, those exploiting the packet streams and those exploiting the wave signals. So, power consumption is an indicator of an electric usage of a system. It carries the information related to either the device that consumes the energy, as the different device have different power consumption profiles when operating, or intensity of the computation in the computing task. It attracts the attention from number of researchers to investigate its link to the sensitive data. This type of attack can be classified into two subclasses: attack exploiting the power consumption collected by the meters and those exploiting the power consumption collected by the oscilloscopes. So, smartphones are the key edge devices in many applications. Different from IoT devices, smartphones have advanced operating systems and a richer system information. Compared with the less advanced IoT devices, smartphones can be exposed to a broader surface attacks. So, attacks can be classified into two subclasses: attacks exploiting the /proc file system and those exploiting the smartphone embedded sensors. So, current defense solution. So, the root cause of the side channel attacks is hidden correlation, which could be very complicated and hardly identified between the sensitive data to be protected and publicly available side channel. Now, defenses against the side channel attack can be performed from the two directions: restricting the access to the side channel information and protecting the sensitive data from the inference attacks. So, there exist no feasible defense mechanisms that can restrict the access to the uncontrollable side channels, leaving the sensitive data protection the only approach for such kind of attacks. Data perturbation. Most well known data perturbation algorithm to protect the sensitive data from inference attacks is k-anonymity, which modifies the identifier information of a piece of the data before publishing its sensitive attributes, making it indistinguishable from another k minus 1 pieces of the data, with these k pieces of the data forming an equivalence class. So, k anonymity suffers from homogeneity attack when the values of a sensitive attribute within the equivalence class are identified. To overcome this issue, I diversity is being proposed by ensuring equivalence class to have at least I distinct values for each sensitive attribute. So, restricting access to the side channel attack, an alternative approach to defend against the side channel attack is to restrict the access to the side channel information. Side channel obfuscation on the source code level is such a scheme to defend from software surface. So, Molnar proposed the mechanism to eliminate the control flow side attacks from the C code, and there are another work which has developed the side channel detection scheme to monitor the abnormal cache behaviors on cloud and edge servers. These two methods directly perturb the side channels to obstruct the accuracy of inference algorithms. Now, in recent years, the development of trust zone technology advances quickly, and this method mainly allows unauthorized access to the side channel that is being protected in the trust zone. So, malware injection attack is shown over here. So, here there exists an edge device and here there are edge servers. Now, attacker sits in between. Now, it will inject the malware and it will inject the malware to the edge devices, a typical architecture here the malware injection attacks. So, the action to effectively and stealthily install malware into the computing system is called malware injection attack. This type of attack is one of the most dangerous ones, since malware is a significant threat to the system security and data integrity. So, traditional internet or a general purpose computer infrastructures where strong computational power is available to support high performance firewall or other threat protection system, malware injection is not always feasible and possible there. Now, typical architecture for malware injection attack is straightforward. The objective of the attack is to inject malware codes to the edge devices or the servers. So, malware injection attack in the edge computing can be classified into two categories: the server side injection, that is injection attack targeting the servers, edge servers, and device side injection, that is injection attacks targeting to the edge devices. Now, server side injection, there are 4 different type of injection attacks targeting the edge servers, namely the SQL injection, XSS, CSRF, SSRF, XML signature wrapping. Now, SQL injection is the code injection techniques that destroys the backend servers. To construct a normal SQL query, the legitimate user is allowed to manipulate only the designated areas to get the result from the server. However, attacker may manage to circumvent this constraint by inputting escape characters along with the query string. Now, cross-site scripting (XSS) is a client-side attack in which an attacker injects malicious codes into the data content, which can be accessed and executed automatically by the server. Note that the client side here does not refer to the edge device side, but rather the edge server side, in which an edge server works as the client to visit or access the services provided by other edge servers or the cloud servers. Therefore, contrary to the traditional general purpose computing system, XSS is a type of injection attacks that happen to the edge server level, the server computing. The attack is caused by the fact that the edge servers do not filter the code from the data content. XSS is not a novel attack and its mechanism has been studied. It is a serious threat to the edge computing infrastructure. Now, device side injections. Now, various diverse methods for injecting malware into the IoT device exist, since IoT devices are highly heterogeneous both in the hardware and the firmware. Most commonly approach to remotely inject malware to exploit zero-day vulnerabilities that can lead to remote code execution. One of the most infamous example of of IoT Reaper virus captured in 2017 that infects millions of IoT devices and Wi-Fi by exploiting at least 30 RC vulnerabilities in 9 different IoT ranging from network router to IP camera. Now, QE discovered RPRFU, that is remote firmware update protocol, by adopting the LaserJet printer allows an attacker to modify a pre-deployed firmware or the printer due to the lack of signature verification checks. Similarly, you know that all these are different type of. Now, defenses against the server side injection also consider 4 major type of attack: SQL injection, XSS, CSRF, SSRF and XML signature wrapping. So, SQL injection attacks were discovered at the time when SQL databases were invented. Defense and detection mechanisms have been studied for fairly long time. Now, detection focused techniques basically employ the code checking with various schemes such as static analysis, dynamic debugging, black box testing, taint based analysis, while prevention focused attack techniques target to prevent any illegal SQL queries from being executed by means such as setting up a proxy filter, employing instruction set randomization. Now, defense against the device side injections. So, injection attacks targeting IoT devices, the main threat comes from the firmware modification attacks. Currently, limited research exists to investigate the corresponding defense mechanisms. Now, there are various ideas are floated based on address space layout randomization, instruction set randomization and so on, and various papers or researchers. They have also proposed the software symbiotic method that injects intrusion detection functionality into the binary firmware of the existing IoT devices. So, the two mechanisms out of that are quite reasonable. Their realizations are never easy, and therefore, specific methods on implementation of the two mechanisms are being looked upon. So, here you can see in this particular figure that this authentication and authorization systems, and here you have the target edge computing system. Whereas, the attacker is concerned, if the direct access is blocked, then unauthorized access is bypassed, and you know that it can make an attack. So, authentication is an action of verifying the user identities who request certain services. So, authorization is a process determining the access rights and privileges of an entity, confirming that entity behaves based on the rights without crossing the boundaries. So, authorization is usually proceeded with the authentication for identity verification. So, in edge computing, authentication is generally performed between the edge devices and edge servers. Under certain circumstances, it also performed that the edge devices or among the edge servers in a decentralized way is also called trigger action platforms. So, authorization in the edge computing often refers to the activity when an edge server grants permission to a certain device or an application. Yet, it is also possible for the devices or the application to grant permission to the other devices in a trigger action scenario, that is in the home automation. So, attack specification of authentication and authorization attacks. If an attacker intends to directly access the protected edge servers or the devices, it would be blocked by authentication system that we have shown in the previous diagram. Therefore, the attacker seeks the method to bypass the authentication process, performing unauthorized access. So, attackers can be classified in 4 types: dictionary attacks, attacks exploiting the vulnerabilities in the authentication protocol, attacks exploiting vulnerabilities in authorization protocols, and over-privileged attacks, with the first 2 targeting authentication protocols and rest are targeting authorization protocols. Now, coming to more details about the dictionary attacks. So, authentication based attacks pose significant threat for securing the edge computing. So, the most straightforward authentication based attack is the dictionary attack, in which an attacker processes a dictionary containing the mostly used credentials password and the inputs of all possible credentials password in this dictionary. Now, this type of attack is also known as brute force attack in terms that is widely used in the industry. Now, exploiting weaknesses in the authentication protocol. So, dictionary attack is an easy to launch. On the other side, it has a serious drawbacks such as high resource consumption and low success rate. Therefore, researchers are investigating more attack by discovering the design flaws of the authentication protocols. There are various works or various proposals they have been mentioning over here, which are still under the development, that is WPA, TLS based authentication, and there are many other which are detected here. Exploiting the weaknesses in the authorization protocols is another way of this authorization based attacks. Usually exploit the weaknesses or the design flaws existing in authorization protocols in order to achieve the unauthorized access, sensitive information, or perform privileged operations, also known as over privileged issues. So, edge computing authorization is a widely used authorization protocol designed for multi-party authorization. So, these are all being now understood that. So, over privileged attacks, you know that basic problem of this authentication protocol is that over privileged issues in typical authorization systems. Now, current defense solution for authentication and authorization attacks. The root cause of the dictionary attacks is the adoption of the weak credentials in the authentication, while the root cause in the other three type of attacks is the protocol level design flaws or implementation level design flaws. So, this authentication is the security entry point of a system, and most attackers take down the edge devices or a server, beginning with the compromising the authentication systems at the first place. Therefore, securing authentication in edge is quite crucial. So, there is a fair amount of work exploiting the dictionary attacks to break possible weak credentials in the edge computing. First is due to the limited computational power issues in the edge infrastructure. Second is, unlike traditional internet applications, edge computing infrastructure have way more subscribers, that is called edge devices. Third is storing credentials in the IoT is not secure. So, these are some of. Now, hardening the authentication protocol is to defense against the attacks. Exploiting the vulnerabilities is to choose to enhance the security of the communication protocol or the secure cryptographic mechanisms. That is what is being taken into the way of by different researchers. Now, hardening the authorization protocol. So, authorization in edge computing infrastructure is equally important compared to the authentication systems. Without properly designing the authorization mechanisms, an attacker can exploit the weaknesses in the authorization systems as well. So, there are many implementation of authentication protocols, and different versions are even theoretically secure. Then there are various works and authentication service providers such as Google, Facebook, and Sina. They first check, and then a lot of new ways are coming which can be exploited using APIs. Now, defending against the over privilege attacks. Over privilege issues mainly exist in IoT based systems and mobile systems. So, there are various scientists. First, they propose the NLP based method to check the inconsistencies between IoT application implementation and its description in order to identify the over privilege exploits. There are different researchers, they apply different methods such as taint based analysis, information tracking technique, and then identify 30 smartphones using IoT guard, and these mechanisms need authorizers to be able to access the source code of an IoT which may not be available at the time. Now, comparison study on the security issues in the edge computing and the cloud computing. So, cloud is a practice of utilizing the centralized remote servers and the data centers in the internet for storage, processing and analysis. The end devices in the cloud are fully far-fetched computer system connect to the cloud servers. Note that cloud systems such as smart things and units and IoT devices usually delegate most of the services to the local hubs can handle IoT, as they are not strictly the cloud. Such systems are now edge computing system. Edge on the other adopts decentralized hierarchical design that may involve low profile devices and computers as the edge servers. The end units is an edge computing system or typically the IoT and the mobile, and they are much more resource constrained compared to the far-fetched computers, and they are connected with Wi-Fi and 4G. So, DDoS attacks. In the flooding based DDoS attacks, attacker tends to exploit the vulnerability of the network protocol of the target system. So, cloud computing typically employs the heavyweight network protocols such as HTTP, HTTPS, FTP, SMTP. Cloud servers are more computational resources for strong security protocols, while the edge computing typically adopts a lightweight network protocols such as COAP, MQTT, UDP due to the resource constraints. So, such a difference makes the attacking effort significantly larger in the cloud computing system, since the compromising the far-fetched computers becoming more and more difficult using the firewalls running on them. So, DDoS attack may no longer effective in cloud computing, but so side channels attacks, if you understand, the attackers have the wide attack surface to launch side channel attacks in the edge computing, as the edge devices are typically connected wirelessly and are more approachable. So, attackers in the cloud often choose to extract valuable information, and cloud computing is typically vulnerable to the side channel attacks that exploit the packet based communication. In edge computing, attackers have more side channel to manipulate, and that can easily access the diverse side channel information. Now, malware injection attacks. Now, attacks targeting the cloud computing, attackers tend to first launch the server side injection to take down the cloud servers and then infect the client devices that compromise the cloud servers, while the edge computing attacker tend to first launch the device side injections to take down the number of edge devices and then abuse them to the edge servers. So, the reason behind such a phenomena lies in the client devices in the cloud are usually not interconnected and taking down few of them may have a limited impact. On the other hand, edge devices in the edge computing are typically interconnected, and thus taking down a few can have much more significant impact if the attacker spreads his attacks among the interconnected devices. Such compromising cloud device is much more difficult than compromising the edge device. Malware injection attacks are more specific and popular in the edge computing systems. Authentication and authorization attacks, both the edge and cloud, are vulnerable to the dictionary attacks. Edge devices have a higher chance of implying weak credentials than those cloud computing, making the dictionary attacks more popular and practical in edge computing. So, edge computing vulnerable to attacks exploiting the weaknesses in the wireless based authentication protocols such as WPA and WPA2, Bluetooth, 4G, 5G, while cloud computing is vulnerable to the attacks exploiting the weaknesses in those SSL and TLS that can be applied to the wired network. On the other hand, even though both edge and cloud are vulnerable to the attacks, exploiting the weaknesses in the authorization protocols. Edge computing is more susceptible compared with the cloud, because cloud has a relatively simple authorization scenarios due to the centralized design, while involving less number of communication parties. Edge servers are deployed in a decentralized manner, involving more communication parties, complicating the whole authorization process. In addition, overprivileged attacks mainly occur IoT and mobile devices. They are typically specific to the edge computing system, since such systems have much more complex access control scenarios and general purpose computing. So, the root causes of security issues, the protocol level design flaws are the fundamental support for the basic functions such as communication, data processing, the edge computing from there. Therefore, designing secure protocol is critical to maintain healthy edge computing ecology. Unfortunately, many current protocols adopted by have the design flaws. So, designers have to focus on utility and the user experience, treating security as unimportant if unnecessary. So, by exploiting this design flaws, attacker can achieve the attack goals ranging from simply shut down a normal service DDoS to fully controlling an edge device or the server, that is malware injection attacks. So, implementation level flaws. Implementation is the process of practically realizing the edge computing functionalities. So, protocol may be proven secure mathematically, does not necessarily mean that implementation is secure. So, logical flaws in implementation can neutralize the security strength of a protocol. So, there are two main reasons leading to the implementation flaw. Developers may misunderstood the foundation of the protocol. Migrating a protocol from other platforms to the edge server may cause inconsistency. So, implementation flaws can equally serious as the protocol level design flaws. By exploiting the implementation flaws, an attacker can bypass the security feature provided by the protocol. Now, code level vulnerabilities. Code is the basic unit of the program that defines the exact execution. As mentioned, many attacks, that is the code level vulnerability is being introduced. Now, implementation level flaw, code level vulnerability are two different concepts, with former mainly referring to the logical flaws in the practical realization. So, the presence of such vulnerability lies thoughtless programming process, when codes for the millions lines of the codes vulnerabilities, an attacker can achieve the attack goals ranging from simply shut down a normal service to fully controlling an edge servers in the malware injection attacks. Now, data correlation, that is in edge computing system, tons of data would be generating from the edge infrastructure constantly, with some of them sensitive placed under the strict protection, while the others are less sensitive and exposed to the public without. Now, there exists hidden correlation between sensitive and insensitive data, which may not be straightforward. Nevertheless, exploiting this correlation and leveraging various attack models can infer the sensitive data, that is side channel attack, or even tamper them based on the insensitive data. Lacking the fine grained access control is one of the most important security measures. Access control, and through which an entity is permitted to access only at least the resources it needs. So, such a measure has a good reputation in protecting the traditional general purpose system for a long time, but it cannot be directly adopted in the edge computing due to the more complex and fine grained scenarios. Now, many current edge computing system implement only the coarse grained access control mechanisms and even do not employ any access control mechanism. Lacking the fine grained access control is specifically designed for edge computing application may significantly lower the bar of launching an attack. That is man in the middle. So, conclusion, in this lecture we discussed various type of security threats in the MEC, that is multi access edge computing, and then we talked about different security threats and the defense mechanisms in the edge computing system. We have also covered about how the fine grained and coarse grained access control are the issues in the edge computing and the authentication protocols. Thank you.